Welcome on day 3 of the course Physics with Scilab. I hope you are practicing the commands and operations I have demonstrated yesterday. In this video, I will demonstrate the commands for getting inverse of the matrix, solving linear equation using matrices, and commands for getting eigenvalues and eigenvectors of the matrices. First, I start with the inverse of matrix. The inverse of any matrix A is also a matrix such that the product of matrix A and its inverse matrix is a identity matrix. So we take first a 3 by 3 matrix M having element in the first row 1, 2 and 6, in the second row 2, 5 and 15, in third row 6, 16 and 46. Now to get the inverse of matrix M, we have this command inverse of M. So let this inverse of matrix M is denoted by variable I. Then this command will give you the value of I. So I is the inverse of M. So according to definition, we must have M into I, that is matrix M, into its inverse must be an identity matrix. So this is the identity matrix. These values minus 4.44 into 10 to the power minus 17, and this value minus 7.105 into 10 to the power minus 16. So these values are very small, hence can be considered to be 0. So then this is a identity matrix. So therefore, we can say that I is a inverse of the matrix M. We take example of another matrix. Before that, I will clear the console by the command CLC. So the matrix N. So I take this matrix N. So it is again 3 by 3 matrix. The elements in first row are minus 2, 4, 8. Elements in second row are minus 4, 18 and 16, minus 16. And in third row minus 6, 2 and minus 20. So let us denote the inverse of matrix N by I. So I is equal to command for getting the inverse of matrix N, inverse of N. So it will give this value. So this is a inverse of matrix N. Let us verify that the N into I is a identity matrix or not. So this is identity matrix. Diagonal elements are 1 and rest of the elements are 0. So these elements having the power with minus signs are very small. So they are 0. So this is how one can get the inverse of any matrix. The condition for getting inverse of the matrix is the matrix must be a square matrix and it should be a non-singular matrix. That means the determinant should not be equal to 0. So suppose if you take the matrix, suppose a matrix V is suppose 2 comma 1 comma semicolon 6 comma 3 Suppose we take this 2 by 2 matrix. So if we take the inverse of this matrix V, so it is showing that inverse is not possible. Why? Because this matrix is a singular matrix. So singular matrix means the determinant of this matrix V is 0. Okay, and for such a matrix we cannot have the inverse. So now we move on to solving the linear equation. So for example, we take the three linear equations. 2x minus 6y plus 8z equal to 24 is the first equation. Then 5x plus 4y minus 3z equal to 2 is the second linear equation. And 3x plus y plus 2z is a third linear equation. So solving these three linear equations means we have to obtain the values of x, y and z from these three linear equations. So these three linear equations can be expressed in terms of a matrix equation. A into x equal to b, where A is a matrix, 3 by 3 matrix, having each row is the coefficient of variables x, y and z of the three equations. That is, A is equal to, in first row, 2 minus 6 and 8, which are the coefficients of the variable x, y and z in first equation. Then second row is the variables coefficients of the variables in second equation, and third row is also the coefficients of the variable in third equation. Then x is a column vector or column matrix which have the elements x, y and z. Then matrix B is also a column matrix having element right hand side of the three equations, that is 24, 2 and 16. As we have written this linear equation in the form of matrix A into matrix X is equal to matrix B. So now suppose we want to get the value of matrix X. So we write X inverse X equal to inverse of A into B. Okay, so this will give you the values of column matrix X which have the element x, y and z. That means the value of x we have obtained by solving the linear equation is 1, value of y is 3 and value of z is 5. So in this way you can get the values of the variables of the linear equations by using the matrix equation. You can directly use this command linsolve for getting the solution of the three linear equation. So first you have to write the first matrix, means matrix A, and then matrix B with minus sign. Remember, here you should write minus B. Okay, so with this command also you have get the same values of x, y, and z. We take another example. So first linear equation, x plus 2y plus 3z. Second linear equation, 2x plus 3y plus z equal to 9. And third equation, 3x plus y plus 2z equal to 8. Again, these three equations can be written in the form of matrix equation: A into x equal to B, where A is the 3 by 3 matrix. Since there are three equations and three variables, X is a column matrix having elements x, y, and z, and B is a column matrix having elements 6, 9, and 8, that is the right hand side of the equations. Okay, so to solve this, we use x is equal to inverse of A into B. Okay, so that we have get from this equation itself. So if it get this A onto the right side, so it will become inverse of A and then into B. So again you will have the same values 1, 3, and 5 for the x, y, and z respectively. Again we use another command for directly get the solution of the linear equation. So first we write A and then minus B. So again we will get the same result. Now eigenvalues and eigenvectors of the matrices. So let us consider the 3 by 3 matrix P having 3 rows and 3 columns: 1, 2, minus 1, 2, 1, 2, and minus 1, 2, 1. So there is a command spec of P will give you the eigenvalues of the matrix P. So the eigenvalues are minus 2.37, then 2, and 3.37. So by using this simple command spec, we can get the eigenvalues of the matrix P. How to get the eigenvectors of the matrix? So to get the eigenvector of the matrix corresponding to the eigenvalues, we use, suppose, the variable eigenvector and eigenvalue. So this is equal to spec of P. So these are the eigenvectors of the matrix P, and these are the eigenvalues of the matrix P. So first column vector is corresponding to first eigenvalue. The second column vector is a corresponding to second eigenvalue, and third column vector corresponding to third eigenvalue. So in this way we can get the eigenvalues and eigenvector for any matrix. Take one more example. Now suppose matrix Q is a 4 by 4 matrix. So to get the eigenvalues of the matrix Q, we use command spec Q. So these are the eigenvalues of matrix Q. To get the eigenvectors, we write in square bracket eigenvect, comma, eigenvalue, square bracket complete, equal to spec of Q So these four columns gives the four eigenvectors of matrix Q, and this each column is corresponding to the four eigenvalues of the matrix Q. Let's try these commands with some popular matrices in physics like Polyspin matrices. As we know, there are three Polyspin matrices. First is 0 1 1 0. Then second matrix is 0 minus I 0. And the third poly matrix is 0 1 0 0 minus 1. So we know very well the properties of these Polyspin matrices. So let's verify its properties with Scilab. So we first see the eigenvalues for the Polyspin matrices. Spec of px, so it is minus 1 and 1. Okay, so similar to our theory, this Scilab also shows this eigenvalue of polymatrix is minus 1 and 1. Then we take the product px into matrix ey, so it is equal to I 0 0 minus I. So this is equal to, this is nothing but I times pz matrix, third polymatrix. Now take inverse of any of the polymetric, suppose inverse of pz, so it is same as pz, means inverse of pz is pz itself. So this pz is unitary matrix. Similarly, we can show that all the matrices are the unitary matrices.